Hello, and welcome back to the second part of a series where I've been exploring what different paradigm for building web user interfaces looks like, particularly focusing on uh, a paradigm that makes us focus on the behavior of applications. What is happening? How do we describe that behavior? How do we better understand behavior? And how that um, behavior is lost in the current component oriented paradigm that have we've sort of been become accustomed to. Um, in the first part of the video, or in the last video that I did the first part, I didn't really walk through this diagram, but I did sort of define the clustering problem, and then we talked about events, how events are generated from user interface. Um, uh, we talked about intentions, so the fact that clicking a certain element in the DOM is sort of meaningless without knowing some underlying intention behind it. And we talked about how usually that's implicitly defined in the way that we attach event listeners in a declarative templating system, and how uh, we just perform things right in event handlers, um, and how I think there's certain patterns that I think are really important to this different paradigm, this different behavioral paradigm, and the first thing is we want to explicitly and declaratively describe the intention of raw events on the elements that they originate from, and then we want to let these events bubble if they can, to whoever wants to receive them. Instead of saying that, maybe I have an element and it attaches some event listeners, and it should respond. Those event listeners should respond to that event locally or bubble up event up the component tree. I think there's a lot of this like complexity that originates from that. And so instead, it's like, what if we just say the view layer, the DOM, should one, render something, make it look good, and then two, it should declare when a DOM event happens. What does that mean? And then we let something else, the behavior of the application, handle that wherever it is deemed necessary. Um, and so that's sort of what we explored last time, and obviously, if I get over there, we're building this game of Simon, and so I created the user interface. I added some intentions to the DOM. You could see on either side of my screen. Um, when buttons are clicked, that there's a certain meaning, like starting the game or toggling the power, or some color is pressed, right? And that's the current boundary of what the view layer has done. And so we've pretty much implemented the view layer in its entirety. And then we're using this custom element and the ability to add attributes to that element that represent the state of our game, and the ability to style this game conditionally in CSS. So there is no templating. We have a shallow semantic DOM here. There's no templating engine, and all of the conditional styling we're doing lives in CSS. If I open that part of our file up, it lives all in here. And so this particular game, the layout is a little tricky because you have to like absolutely position things, and it's a little tricky. But you can sort of see as we get down to the bottom here, depending on like the state of these attributes, maybe the strict mode is on, or maybe the display of our screen turns off if the game is off, and when the game comes on, the screen fades in or something like that. So that was all implemented last time. And so what we ended up with is we ended up with this custom element, and we had an event handler that pretty much allows all events to bubble up to it, and uh, and we currently have 4 different intentions that could happen in our game. And so what this event handler is doing, what we didn't implement last time, was when those intentions happen, how do we respond to the game? And so I've gone ahead, and just to save everyone time, I've implemented what I would consider like the traditional way that we've defined behavior using this approach. And so what's really nice is all of the events that happen in this particular web user interface are clustered together. They happen they are all processed in one place. So we don't have the problem that you typically have in a component-oriented paradigm where you respond to events in components, and those components only have a certain set of state that they either own or they're passed down, and they need to use that state to either respond to that event directly or to bubble up that event. And what the immersion that happens there is it becomes really hard to understand behavior, because to understand the entirety of behavior for an application, you have to understand every single component. And so the whole locality of behavior and view and state sort of breaks down in that particular paradigm or mental model, in my opinion. And so what we're doing here is we're sort of exploring the opposite. What if there's one place that handles all of our events? We don't need to know where they come from. We just need to know what they mean. And we can extract what they mean and then respond to it. And the way we respond to it is by very simple DOM manipulation. A majority of the time, it's just setting DOM attributes on our custom element, projecting some state into the DOM that we can conditionally style. We've already talked about that. Or in certain cases, and this game isn't most highly interactive, it could be actually having to update the DOM. So you'll see that as I walk through this in our display, right? We need to actually like set the text of our display so that it displays the sequence we're on. And so before we dive into the actual behavior, this is what's important to know. One, I'll walk through the game, how it works, and actually play through it, and then I'll walk through the code. But before that, the reason this part 2 isn't actually exploring any new patterns of this paradigm. It's setting us up to understand the fallacies and faults that we see when we define behavior in sort of an imperative way. So actually, this is in a lot of cases, and as complexity increases, we'll actually be able to, through this example, we'll be able to see there's actually a lot of edge cases, and even in the way I've implemented this, there's probably bugs and edge cases that are not handled. And that comes from the fact that we don't have behavioral notations that provide guarantees around what state are we in, are we transitioning between those states properly. And so in the next video, what I'm setting up for is I want us to understand, let's understand how we can implement this behavior in a very imperative, what some call like a bottom-up approach. And then we'll actually fix that in the next video and start using the next patterns of this behavioral paradigm and implement the behavior using a particular notation called state charts or state machines. And the guarantees at the end, we'll hopefully this sets us up to highlight the differences and the guarantees that that approach and those patterns give us compared to the like bottom up approach that we typically work in. There's a great book on this called Constructing State Charts, Constructing User Interfaces with State Charts by Horak, I think. It was a book that came out in like 1999, and it's one of my favorite books on constructing user interfaces, because the way he describes the problems of like how we typically build user interfaces, it's a really powerful framing. And also it's just so interesting to see that it's still the de facto in how we build user interfaces today, even though that book is almost 25 years old. um, so if you can get your hands on that, I highly recommend reading that in the meantime, before the next part of the series comes out. Um, so yeah, without that, let's actually dive in. So the behavior of this game is pretty easy. Currently, we're in an off state, and you can see that here. If we turn on our game, we get this little boot up animation, and we're sort of we could click buttons, but it's not really going to do anything because we haven't started playing the game. So we can toggle strict mode on and off, if depending on how we want to play. All that means is strict mode. If it's off and you get a sequence wrong, you can retry from where you were. If strict mode is on, then you can't retry. You lose the game. So that's what strict mode does. And then if we press start, what you'll see is we're currently on sequence one. We're currently on sequence one, and a light flash, and so we need to mirror that. So I'm going to press the blue button. You see a little animation that says, hey, you got it correct. And then the next sequence comes on. So it was blue and then red. And then you can see I got that right. So blue, red, red. So blue, red, red. We have sound that's playing as you press this buttons, and while the sequence is displayed. So it's blue, red, 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 red. I got that correct. So, four reds. Blue, red, 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 red. And then you could see right now the game is programmed. So if you hit a sequence of 5, you win the game. Typically it's 20, but just for demo purposes, it's easier to test when that number is a little lower. And you could see like there's a little screen that says, flashes you in, and then the lights flash, and then the game resets. So now we're sort of in idle, right, waiting for someone to start playing the game again. Just to show strict mode, if we start with strict mode on, was red pressed? Yeah. Red is feeling it. So if we do red blue, what you'll see is we're gonna go back to the idle state, right? We're in strict mode. We lost the game. Maybe at some, if we wanted to, we could program a little thing that says you lose or whatever. But that's sort of trivial to add. So that's sort of the behavior of this game. It's seemingly simple on the surface, but what makes this particular game really tricky to coordinate, and why I know there's a lot of edge cases and bugs just waiting to be found, is there's a lot of asynchronous behavior. So when you play those sequences, you need to both play the sound, light up the button, and then when both of those are done, you need to move on to the next sequence. Then you need to wait for someone to play, press a button and work through the sequence. And while that's happening, you need to play the sounds of the button they press. And it's both simple and infinitely more complicated than you would think on the surface. And that's where I think a lot of bugs come in. And part of the behavioral program, the paradigm that I'm exploring, is figuring out how can we describe behavior in a way that guarantees that a certain class of behavioral related bugs don't happen. And you're very prone to do that in this imperative way, where we're sort of just saying, typically associated, you could be a switch daemon or like a redux, where we're just saying, hey, an event came in, let's do something with it. And if you look up this event, you can sort of see we're doing something by like introspecting the current data, the current state that we have. So when someone turns on or off the game, when they toggle the power, we say, hey, if we're in off or if we're not in off, then we need to shut the game off and the mode becomes off, and otherwise we're going to start in an idle state. Um, and then there's certain side effects depending on that switch as well. So if the mode is idle, um, uh, after we change it, um, uh, if we're now in idle, then we want to play the start sequence that I displayed before, and I'll walk through this method. And if we're turning the game off, then we want to reset everything, right? If someone shuts the game off in the middle of the game, then we want to reset the sequence and all the state associated with like what they have. So that's seemingly easy, but you can already sense this like, what if and there's only like the mode is either like on or off, right? This button's only turning the game on or off, but um, what you sort of see in this like bottom up approach to describing behavior is you're recreating the state space or the finite set of states that represent this game because we haven't explicitly defined them. Um, and we'll see that complexity a little more in a little bit. So that's the first intention and how we respond to it, right? And just to clarify here, mode is a getter setter, and we're in this case we're sort of saying that this state is actually like part of the DOM. So when you interact with mode, it might look like a regular property on a class, but it's actually just getting and setting an attribute of that class. And you can see the same thing with strict as well, right? Strict is just an attribute as well. Getter and setter. Right, and so that brings us to a next intention, which is strict mode. So and again, we're going to see more of this conditional logic build up as we walk through the game, but strict is an intention that we only should do something if the game is on. So if it's off, then we're just saying, hey, we're going to ignore this intention. Someone might have pressed the button, but given the state or the mode that they're in, we don't want to do anything. If the game is on at any point, then we're just going to toggle strict. We're just going to say, hey, it's on right now, and turn it off. There's some nuance here depending on how the behavior of the game works. If you could totally make it so that if strict mode is turned on in the middle of a game, that it like resets the game from scratch, so you have like a true strict mode. This is sort of the easier behavior to implement, which is you could toggle strict on in the middle of the game if you want, and it's just going to be strict from there on out. Both of those are valid types of behavior that you could implement. It's sort of up to you and what you want your game to be. So I think in this I'm not going to be as strict as or pedantic as I need to implement this particular strict mode. Then we're getting to the crux of implementing this game. So when the user declares an intention to start the game, they press the start button. If the game is off or we're already playing, and again, this is sort of up to interpretation of the behavior, we're not going to do anything. So if someone's in that sense, there's no way to restart the game besides turning the console on and off. If you wanted to, you could very easily say, only if the game is off, then start should do nothing. If we're playing the game, then we could start could be like a restart kind of button. That's up to interpretation. Very trivial. It will take like 2 lines to change to get that behavior if that was the desired behavior. But in this case, I think it's fair to say if we're playing and you press the start button, it's just going to be ignored. And you can if that condition passes, what that means is that the game is currently in idle and we're ready to start the game. So we're just gonna add this extra check that just resets everything, just in case it wasn't cleared. That's sort of defensive, but also sometimes necessary. We'll get into this method in a little bit. We're gonna set the mode to playing, so we have a new mode that we just unlocked. It doesn't change any of the styling of the game, but it just indicates that we're playing, and we'll see why that's important in a little bit. And then what we're gonna do is we're gonna add a sequence, a color to the sequence of the game, and then we're gonna play that sequence out and wait for the user to press some colors, which is implemented here. Our sequence is just a list of these colors, and we have a number that sort of keeps track of what index, right, or what part of the sequence is the user on, if that makes sense, right? So every time you add a new color, we sort of have to we have to replay through all those colors, and that sequence that we keep track of, like where we are in the sequence. So that's what happens when we start the game. As you can see, this is an asynchronous. To play this sequence is an asynchronous operation. So we're awaiting on playing the sequence, but while the sequence is playing, any number of buttons can be pressed that do something, right? If we're playing the sequence out, and let's say that takes like a second, right? I could turn the game off. I can toggle strict mode. I could press these buttons. And the reason that this behavior becomes really hard to enforce is while the game is starting and we're playing a sequence, like we need to restrict buttons can be pressed or interactions can happen, and we need to like defensively prevent that from happening because we have no mechanism to do that in in the JavaScript language or most general purpose programming languages. And so we're going to see that amplified a lot when we get into the crux of this behavior, which is what happens when a color is pressed. And already you can see that there's a lot of conditional logic here to figure out what to do when a button is pressed, because it's highly dependent on the state of the game that we're in. So you can already see, and I haven't walked through some things, and I'm probably going to walk through that in a second. You can already see if a color is pressed and we're either playing a sequence or we're not playing, then we're not going to do anything. It's open to interpretation, but you could say if maybe the game's on, we're in an idle state, and you press a button, you might want to hear a sound. Totally reasonable, and that's again something we could change for this purposes. I've just simplified it a little, the tiniest amount, but you can already see where we have to be very defensive about when is a color pressed, and so let's talk about this. Sort of talking about playing a sequence is asynchronous. We have to play the sounds, wait for the sounds to finish, light up the button while that's happening, wait for turn that off. So this is like an asynchronous operation, and in the case where we might have a sequence of like 20, where we might have like 20 or whatever colors in a sequence, like that could take like 10 seconds, for example. And the user can do whatever they want in that time span. So let's actually dive into this particular function. First, I'll just walk through this. This might seem a little obscure, but we're essentially just picking a random color, pushing it onto our sequence. Whenever we add a new color to our sequence, we're going to reset the index that we start at. That means the user has to click through all the buttons again, and then we're also going to update we're going to update the text of the display as well. Anytime we add a color to the sequence, that means you have a new score. I realized I sort of did this wrong, because if you add something to the sequence, we might want to do this before. If we do this before, then it'll display the number of sequences that you have gotten as opposed to the one you're doing right now. So that, again, that's sort of up to debate. I'll keep it down here for now, but that's how we add a random color to the sequence. And then this is a really interesting set of logic here. So to play a sequence, we're given a list of colors, a delay to take in between each of those colors, and whether we want the sound to play. We loop through those colors. We grab the audio, HTML audio element that for that color. We grab the button for that color. Those are defined up here, sort of hidden. It's just a query selector when this class is initialized, and because we just have shallow stable DOM, we could just do that. There's permanence to these elements, and the query selectors are very easy. So those are our audio. Those are our buttons and our audio elements. And once we grab those, we set an attribute that says this is the active button. There's some conditional styling that's going to display, lighten that color up, as you can see here when I hold this down, right? If we want a sound to play, then we await this method that plays the audio sound. A little trickier than you would think. I could show you how to implement this method. And then what we do is we wait a little bit in case the sound isn't displayed. So instead of waiting for the sound, we just wait for the delay. We remove the attribute, and then we have a second delay. So I'm not entirely happy with how this came out, but essentially in the case that we're playing no sound, we want a delay to happen. It could be an else statement here. It could be something like this. It could be something like this. So if there's a sound, await the sound. Otherwise, await the delay or something. It's sort of equivalent. Now we remove the attribute and wait a little bit before we move on to the next color. Now, while this is happening, we set a Boolean flag that says, hey, a sequence is playing. That means if other colors are clicked or other user interactions happen, we might want to guard against those. And so currently the only guard that we have, because the other ones are sort of reasonable, is if a sequence is playing, then ignore all other color presses while that's happening. So you could already see this is really defensive code. And so let's minimize that. To play a sound, sort of interesting. We're using a newer what do you call it? We're using a newer standard that has sort of made it in the browsers that lets you create a promise, and it sort of pulls out the resolve and reject helper, so you could use that outside of things. So what we're going to do is we're going to return that promise, and then we're going to add an event listener to the audio element that tells us when it's finished playing. When that happens, we're going to remove that event listener and then resolve the promise. Once all this is set up, we're going to play the sound. So unfortunately, there's no promise-based method to playing audio in the browser. So we sort of have to create a little wrapper that does that for us, which is interesting. Probably as clean as you can get. This helper is super cool, very, very helpful. That sort of brings us to that. Those are some of the methods that we have that I had to write. I guess I didn't show the reset game. Pretty simple. We just clear the sequence out, reset the index, reset the display and set the mode to idle when we reset the game. Yeah, so that brings us to the rest of this fun logic. The So let's say these conditions pass, right? We're playing the game. There's no sequence playing, so that means the user pressed a color, and we actually want to do something with it. The first thing we're gonna do is we're gonna grab the target of that intention. So in this case, these buttons, and there's an implied contract here that each button has a color on it, has a color attribute. So what we want to do is we want to get the value of that attribute. If there is no attribute, then we're just going to ignore that intention because it's not valid. We need a color in order to actually process anything. The first thing we're going to do is we're actually going to play the sequence of just that color. So we want to play the sound, and yeah, there's sort of two ways to light a button up. One is programmatically with the active attribute, like I just explained. The other one is to actually like press on it. So we're gonna play that sequence because we want to play the sound. I guess we could make this 0 too, so we don't really care about a delay because the user is like holding it down or it's playing, because a user can just tap on it and we still want to show that it's a sound is, we want to like show feedback that it's playing, and while it's playing we want to show that it's red. So we're gonna wait the sequence playing. We're then gonna figure out if their guess is right. So we're gonna take the current index that we're pointing to. We're going to look up that color in the sequence, and if the color that they guessed is that, then it's correct. So I'll get to if it's correct, if it's correct logic later. If it's not correct, if they guessed wrong, and we're in strict mode, then we're going to reset the game. Pretty self-evident. If they guessed it wrong and they're not in strict mode, what we're gonna do is we're gonna just show our little sequence that shows, hey, you got it wrong. And what I do is, instead of playing animating the sequence this way, so red, blue, green, yellow, we do it in reverse. So it feels like a little jarring. It feels weird, and that's because it's trying to indicate that you got it wrong, right? So we play that sequence, and then we play the actual sequence that you have to remember again. So it's important to note we don't play the sound when we're like showing you that you got it right or you got it wrong. We only play the sound when it's like we're actually showing you something that you need to remember. So these are the two conditions if you guessed wrong. If you guessed right, then there's all this other logic that we need to do depending on the current state of the game. So first, what we do is we have to check if you've reached the end of the sequence, right? So if the current color that you just clicked is the last color in the sequence and you got it right, there's a whole bunch of things that we need to do depending on the state of the game. Otherwise, you haven't reached the end of the sequence, so you still need to finish clicking through the sequence to get to the end. So in that case, the only thing we do is we increase the index of where you're at in the sequence because you got it right. If we are at the end of the sequence, the first thing that we do is we check if you've reached the maximum length of the sequence. So in this case, it's 5. Usually it's 20, so I'll just put that back here. And then we're gonna display that little "you win" with the sequence animating, right? So we're gonna change this to "you," animate the sequence, change it to "win," animate the sequence in reverse, and then we're gonna reset the game. We're gonna go back to an idle state, wait for you to start playing again because you've won. If we haven't reached the maximum sequence, what happens is that means you've gotten the current sequence correct and we need to add a new one on. So First thing we do is we display the little wheel, the little light up wheel that says, "Hey, you got it correct." And we're gonna show some feedback that you've made it to the next round. We're gonna wait a little bit just to add some space in between. We're gonna add a random color to the sequence, and we're gonna animate that sequence out and wait for you to guess the next set of colors. That's what that logic's doing. It's unfortunate that it gets really nested. I think it becomes more confusing, and I'm sure there's ways people can figure out how to organize this code better. I'm not really too worried about that. The point that I'm trying to make here is if we don't have the ability to describe behavior, and we're doing it in this bottom-up fashion where we're, when an event comes in or an attention comes in and we need to respond to it, we need to recreate, we need to figure out where we are in order to do what we need to do, right? And I think that that approach is sort of backwards, and is really prone to bugs. And it's prone to a lot of edge cases that you wouldn't even imagine until they happen, and you need to even figure out how to reproduce them. And so what intrigues me is if we're trying to figure out what a behavioral paradigm for building web user interfaces is, how can we guarantee that class of bugs, that set of bugs, doesn't happen? And that's what part 3 is going to talk about. We're going to talk about state charts. We're going to model this the behavior of this application declaratively, and then we're going to pull that behavior in and sort of refactor what I have here in order to more or less eliminate a majority of these bugs. And most of these edge cases that I'm referring to really have to do with the behavior that we're awaiting, that is asynchronous, right? We need to await certain things in order to do the next set in the sequence. And async await is great. It sort of works here, but it's not bulletproof. And you either need to create significantly more defensive code in order to prevent that from happening, or you need to have a different approach, or you just accept that there's going to be bugs, and that's okay. And so that's the behavior of this game, implemented in a very typical bottom-up fashion, and it works. Using it for simple things, it could be all you need, right? I've implemented all 7 of the 7 GUI challenges, which is 7 distinct types of user interfaces that you implement. And for a lot of those, all I really to implement it with this type of approach, or in the patterns that I've been talking about, all I needed was switch statements. There wasn't really a lot of state in those things. It was sort of just updating an input or whatever, which is great. It'll get you far, but there are certainly cases like this game where I think there's a limit to how far this approach can get you. And if you're still trying to reach a certain level of robustness and understanding what's actually happening, it gets increasingly hard. And so we'll talk about that in part 3. If you have any questions, thoughts, concerns, for sure add a comment or ping, message me, and I'd be happy to talk about it more. Till next time, thanks for listening.